A long time ago, before GPS and even before compasses were widely used, there was Polaris, the North Star. This single star, almost directly above Earth's north axis, never sets below the horizon. Well, not exactly never. The Earth wobbles a little on its axis over time, shifting Polaris off its throne. But compared to other stars, it's basically motionless, making it a natural and extremely convenient reference point. People have used it for everything from navigation to agriculture to keeping time, and it's such a prominent feature of the night sky that many cultures have woven it into myths and legends. To the ancient Greeks, it was the rudder that steered the great ship Argo. To the Inuit people, it was a drum that provided light for drum dancers during the long polar nights. For the Chinese, it represented the heart of the Jade Emperor. Through the ages, Polaris has been a constant companion, watching over humanity and silently guiding our steps. But here's the irony. For all its importance to humans, Polaris holds a peculiar secret. It's hiding something that's baffled scientists for decades. In a way, it's the ultimate cosmic joke, the one star that everyone knows so well, that's actually the most poorly understood. Here's why. Polaris is special. First, it's one of a rare class of stars known as Cepheid variables. They're middle-aged stars like our Sun, around 6 billion years old, that have expanded into red giants and started pulsating. But unlike most of these stars, which are too far away to do more than twinkle in our sky, Polaris is relatively close. It's only about 320 light-years from Earth, making it the brightest Cepheid in our cosmic backyard. And it's this proximity that has made Polaris both a blessing and a curse. We see it more clearly than any other Cepheid, but that same clarity has revealed peculiarities that no one expected. In the 1950s, astronomers realized that Polaris was changing, slowly weakening over the course of decades. This wasn't supposed to happen. Their models predicted that a star like Polaris should brighten over time. So why was it getting dimmer? And if it was genuinely fading, how could they use it as a cosmic ruler? That last question is critical. Using distant Cepheids to measure the distances between galaxies relies on the assumption that they're consistent. But if Polaris was fading, it could mean that all our distance calculations were wrong, throwing our understanding of the universe into chaos. So astronomers worked overtime to solve the Polaris puzzle. At first, they suspected that the dimming had to do with its stellar companions. Stars often come in systems where each one influences the other. Even subtle gravitational tugs can affect a star's brightness. But after analyzing the data, astronomers ruled out this possibility. The change in Polaris's brightness was simply too extreme to be explained by any known stellar interaction. They went back to the drawing board and re-examined their models. Maybe they'd made some fundamental mistake in how they understand Cepheids, but after years of work, they couldn't find anything wrong. Just when it seemed like the mystery would never be solved, something unexpected happened. Polaris began to brighten again. After decades of steady dimming, it started pulsing with renewed vigor. Astronomers were stunned. They had predicted that a fading giant would get brighter as it neared the end of its life. But Polaris was doing something they hadn't anticipated. It was stabilizing, perhaps even recovering. It's hard to overstate just how weird this is. There are roughly 200 known Cepheids in our galaxy, and not one of them has shown this behavior. Polaris is literally a one-of-a-kind phenomenon. Now, it's not quite the cosmic rule-breaker you might imagine. Polaris's brightness hasn't returned to what it was before the dimming episode. It's still a bit weaker than it was in the 50s, but the fact that it's no longer fading is a relief for astronomers. They can keep using it as a cosmic yardstick. But the bigger question remains, why did Polaris dim in the first place? Astronomers don't know the answer. One team suggested that it had something to do with its invisible companions. Maybe a bit of fine-tuning needed to take the strange gravitational interactions into account. Another team blamed a cloud of gas and dust around Polaris, arguing that it blocked some of the star's light. But neither explanation could fully account for the dimming, leaving the puzzle only half solved. In recent years, new theories have emerged. Polaris may have entered a rare and unstable phase of stellar evolution, shedding mass at an unexpected rate. Or its dimming could be linked to changes in the core of the star, possibly caused by the fusion of helium into heavier elements. But without more data, it's impossible to say for sure. So Polaris continues to hold one of modern astronomy's greatest mysteries. Now, here's why that's a big deal. While Polaris may seem like just a pretty star, It's actually one of the cornerstones of modern astronomy. It's not the only Cepheid variable, but its relative closeness makes it the easiest to observe, giving it a unique role in our quest to understand the universe. First, let's talk about how we use Cepheids to measure cosmic distances. Back in the early 1900s, a Danish astronomer named Ejner Hertzsprung noticed a strange thing. Certain stars seem to have a very particular relationship between their color and their brightness. Specifically, the bluer stars were also brighter. At first, he thought it was a coincidence, but soon enough he realized he was looking at something extraordinary. Each point on the graph represented a star, and those stars formed a distinct band across the sky. Hertzsprung recognized that this pattern wasn't just a random grouping. It was a key to understanding stellar evolution. He had uncovered what's now known as the Hertzsprung-Russell diagram, a fundamental tool in astronomy that helps us classify stars based on their characteristics. Over the years, astronomers built on Hertzsprung's work. They found that while most stars tend to fall along a main sequence, tracing a diagonal path across the diagram, certain stars deviate from this pattern, especially bright and luminous stars like Cepheid. These outliers stand out because their position on the HR diagram tells us exactly how far away they are. Cepheids have a built-in cosmic speedometer. The faster they pulse, the brighter they are. And by comparing their apparent brightness with their intrinsic brightness, astronomers can work out their distances. Once they have that information, it's like having a yardstick for the universe. They can use Cepheids as reference points to measure the distances between galaxies. That's why Polaris is so important. It's the closest Cepheid to Earth. Having such a nearby reference point allows astronomers to calibrate their instruments and test their models with greater accuracy. But here's the catch. To use Polaris as a reliable yardstick, we need to understand its behavior. And as we've seen, that's not as easy as it seems. In the 1990s, for example, astronomers searching for extrasolar planets struggled to confirm the existence of one planet around Polaris, because the star's fluctuating brightness made it hard to distinguish real signals from noise. Then there's the issue of mapping the universe. The success of using Cepheids as cosmic rulers depends on assuming that they're consistent and unchanging. But Polaris's dimming episode raised concerns about just how accurate these assumptions were. Was it a one-off event or a sign of something more widespread? Now, thankfully, Polaris's brightening has eased these concerns. It showed astronomers that Cepheids aren't necessarily as volatile as they thought. But the fact that Polaris behaved so erratically in the first place highlighted the need for caution. The stability of the entire cosmic measuring system built on Cepheids hinges on our ability to pin down their behavior. And that process starts with understanding one star, the North Star, whose ways are more mysterious than anyone imagined. So as we look up at Polaris, let it be a reminder that even the most familiar things can still hold profound mysteries. The bright star that's guided humans for millennia is, in a sense, still guiding us, showing us that the universe never ceases to surprise. Perhaps the greatest irony is that Polaris, the star that has illuminated our path for so long, is now illuminating a new path for astronomy, urging us to explore and understand the uncharted territories of stellar science. Just as Polaris has remained fixed in our sky, guiding generations of explorers, it now guides our gaze inward, challenging us to unravel the complexities of the cosmos. It's a fitting role for a star that refuses to be measured, forever pushing the boundaries of what we know, reminding us that the universe is as boundless as our curiosity. The future of astronomy may well depend on our ability to solve the riddle of the North Star. And who knows, perhaps the answer lies not just in peering deeper into space, but in looking more closely at the faint starlight that has been with us since the dawn of time.